Students, if you like this video, please subscribe and share it. Don't forget to like it. Now I am going on. Topic is permutations. Now remaining other models are discussed. Now the value of sigma r is equal to 1 to 10 r into PRR is. Now here PRR means RPR. RPR. Now we know that NPR, n dissimilar things taken R at a time, NPR. N dissimilar things taken R at a time is NPR. Now we have RPR means R dissimilar things taken R at a time, RPR is equal to R factorial. RPR value is equal to R factorial. Okay, now here first find sigma R is equal to 1 to 10 R into PRR. Now sigma R is equal to 1 to 10 R into R factorial. Now here plus 1 and minus 1 add and subtract 1. Now is equal to sigma R is equal to 1 to 10 R plus 1 minus 1 into R factorial. Now multiply with R factorial both. Now sigma R is equal to 1 to 10 R plus 1 into R factorial. R plus 1 factorial minus 1 into R factorial is equal to R factorial. Now R plus 1 minus R factorial. Now here R is equal to 1 to 10. Now here 1 to 10 values are substitute this one. Now here first here substitute 10. 10 plus 1, 11 factorial minus 10 factorial. 11 factorial minus 10 factorial plus next 9. 10 factorial minus 9 factorial. Next 8. 9 factorial minus 8 factorial plus up to so on. Last value is 1, 2 factorial minus 1 factorial. Now here 10 factorial plus 10 minus 10 minus 9 plus 9 all are cancel, minus 8 factorial before 2 factorial cancel. Only here 11 factorial minus 1 factorial. Okay, 11 factorial can be right 11p11 minus 1 factorial value is 1. 11p11 can be also right p1111 p1111 minus 1. Therefore option 2 is the correct one. Next one, the value of 1 plus 1 into 1 factorial, 2 into 2 factorial, 3 into 3 factorial plus up to so on n into n factorial. Now here given problem based on your small concept. Now 2 into 1 factorial is equal to 2 factorial. Now 3 into 2 factorial is equal to 3 factorial. Now 4 into 3 factorial is equal to 4 factorial. Now up to so on n plus 1 into n factorial is equal to n plus 1 factorial. Now here given 1 plus, now 1 can be right 2 minus 1 into 1 factorial plus 3 minus 1 into 2 factorial plus 4 minus 1 into 3 factorial plus up to so on plus up to so on n plus 1 minus 1 n plus 1 minus 1 into n factorial. Now here 1 plus 2 minus 1 into 1 factorial. 2 minus 1 into 1 factorial. Now 2 into 1 factorial, 2 factorial minus 1 into 1 factorial, 1 factorial. Now 3 into 2 factorial, 3 factorial minus 2 factorial. Now 4 into 3 factorial, 4 factorial minus 3 factorial plus up to so on. Now n plus 1 into n factorial. N plus 1 factorial minus n factorial. Now here all are cancelled. 1 factorial, 1 also minus 1 factorial plus 1 factorial. Now plus 2 factorial minus 2 factorial. 3 factorial, 3 factorial. Next term 4 factorial cancel, also n factorial is equal to n plus 1 factorial. Therefore, final value of given problem. Now here n plus 1 factorial means option 4 is the correct one. Next one, the remainder obtained when 1 factorial plus 2 factorial plus 3 factorial up to so on plus 49 factorial is divided by 20. Now here is divided by 20 means, now sum of the first number 4 members divided by 20, that's remainder is equal to total given expression of the value divided by 20 equal to total expression of the value divided by 20. Now here sum of the first 4 members. Sum of the first 4 members means 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial. Now 1 plus 2 plus 6 plus 24 now is equal to 33. Now 33 divided by 20. Now 33 divided by 20. Now remainder is 13. Remainder is 13. Therefore, total given expression divided by 20 means remainder is 13. Therefore, option 1 is the correct one. Option 1 is the one. When n factorial plus 1 is divided by any natural number between 2 and n, then remainder obtained is. Now between 2 and n means n is a natural number. Now consider for n is equal to 5. Now n is equal to 5. N is equal to 5 means given expression n factorial plus 1. Now 5 factorial plus 1 is equal to 120 plus 1 is equal to 121. Now 2 and 5, between 2 and 5. Now between 2 and 5 means, now you take 3, 4. Now 121 divided by 3. Now 346, 120. Now remainder is 1. Now 121 divided by 4. Now 30s, and here also 120, and here also remainder is 1. Now you consider any value for n equal to 5 or 6 or 7, anything up to n is a natural numbers means, now between you take any two numbers. Now divided by two numbers means remainder is 1. Therefore, now here n factorial plus 1 is divided by any natural number between 2 and n is, remainder is 1. Therefore, option 1 is the correct one. Next concept is dearrangements. Formula 1. The number of ways in which exactly all letters can be placed in wrongly addressed envelopes when n letters are put in n addressed envelopes is NPR into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus up to so on minus 1 whole power r into 1 by r factorial. Second one, the number of ways in which n different letters can be put in their n addressed envelopes show that all the letters are in wrong envelopes is equal to n factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus up to so on plus minus 1 whole power n into 1 by n factorial. Next, third one, the number of ways that all the letters will go into correct addressed envelopes is only one way. Next, fourth one, the n letters are kept in n addressed envelopes, then the number of ways that exactly one letter will go wrong is 0. The number of ways 5 letters put in 5 addressed envelopes show that one letter is in right envelope and all the remaining are placed in wrong envelopes. Now here one letter is right envelope means remaining 4 letters are in place. Remaining 4 letters are in place wrong envelopes. Now required number of ways is equal to required number of ways is equal to, now using formula 5p4 into 1 minus 1 by 1 factorial. Now here r value is 4 plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial. Now 5p4 value is 120. Now 120 into 1 minus 1 factorial value 1 by 2 plus 1 by 6 minus 1 by 6 plus 1 by 24. Now here LCM 1 cancel. Now 120 into now 120 into now LCM is 24. Now 12 minus 2 minus 1. Now 24 fives. Now 5 into 9. 5 into 9 is equal to 45. Therefore, the required number of ways is equal to 45. Option 2 is the correct one. Next one, the number of ways that all the letters of the word SWORD can be arranged show that no letter is in its original position is. No letter is in its original position means now using Dearrangments formula. Now here given word contains 5 letters is there. Now here n is equal to 5. Here n is equal to 5. Now required number of ways is equal to now 5 factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial. Now 5 factorial value is 120. Now 1 cancel. 1 by 2 minus 1 by 6 plus 1 by 24 minus 1 by 120. Now here 120 into, now our LCM is 120. Now 60 minus 20 plus 5 minus 1. Now 120 cancel. Now is equal to 45 minus 1 is equal to 44. Therefore, the required number of ways is equal to 44. Option 1 is the correct one.